I will speak mainly about how we work within our own factories on an everyday base, but I will also touch briefly how we also serve our customers. SKF has been around for quite a few years. We have a legacy of more than 100 years, and we have roughly 100 factories spread out. And a lot of our factories are quite old, and a lot of our machines are quite old. So we have the challenge of maintaining our old equipment at the same time as we have new equipment coming in with new technologies. We have a very big and senior and extremely skilled workforce, and we have new employees coming in with new competences. And I feel that the challenge for us is to balance this. But more than 90% of our machines are the old machines. And those old machines, we need to find a way to update, upgrade, sensorize, extract data from, so we can work in a better way with them, because we will live with those machines for quite a few years to come. And in the same time, having the new fully automated machines coming in, requiring a completely different skill set and approach than the old ones. So my role within SKF is that I'm responsible for manufacturing reliability. So my team defines how we should work with maintenance globally within SKF when it comes to standard practices and methods. So I will touch a bit upon that. We have a vision and mission in SKF, which we use quite a lot internally. That in a world of reliable rotation, we want to be the undisputed leader in the bearing business. And why I highlight this is because we use it in our factories. So in order to be that, we need to have our machines under control, not having the machine to control us. We need to work in a much leaner way, reducing variation in our production. Not only with new machines, but old machines. And going back a few years, if I go back 10 years, when I was the maintenance manager for the factories here in Gothenburg, we started using and reviewing better methods, better updated methods. And it was a big challenge. Back then we started to use what today is very basic: thermography, shaft alignment, belt tension, frequency meters. But this was where we started to capture the first data. And this was a challenge to start with those basic tools. But it's where you start. Start with what you have. And then we have developed from there in different areas and in different factories. We have gone further. We opened a new manufacturing area in Gothenburg now 3 years ago. We call it world-class manufacturing, where we more or less fully automated the production. So we went from 130 operators down to 30 with an increased output. But this is an isolated area. This is not representing the full SKF. And I think this is the challenge. That area requires a completely different set of how we work. There we have the data. The question is which data that are valid. And one of the challenges is, and I'll take an example I heard from a colleague saying that if you take the whiskey consumption in Scotland, it goes like this. And you take the amount of priests in Scotland, it follows that consumption to 100%. You can do the assumption that the priests are consuming quite a lot of whiskey. But if you add a third data to that, and that is the development of the population, it also follows. So the more people there, the more whiskey is consumed. The more people, the more priests. So we are in a phase where we're trying to understand which data is actually telling us something and which data is nonsense data. And how does this data need to be correlated with other data to tell us something? So, and within our factories, we have a very standardized process. We start by doing an assessment where we review the organization from a maintenance perspective, where they are. Do they have maintenance engineers? Do they have planners? Do they have strategies? Do they have KPIs? How do they build up their preventive maintenance program? Because in SKF, we don't maintain machines. This we have stopped to do. We maintain components' ability to deliver their intended function. This is what we should ensure. And then we look, okay, what could the failure mode of this component be, and what would that cause? And based on that, we can also evaluate what sort of counteractions we need to do, or if we should just run to failure. If the solution is an expensive solution, we would look at the severity of accepting that failure. In some cases, it costs more to take away the failure than actually accepting. So we do this, and then we see where they are, and then we start to define where should they go. From mean time between failure, number of breakdowns, mean time to repair, so different KPIs. Spare part cost is something we're focusing quite a lot. There we see the biggest savings, more or less. And then we go to the machine and we see, okay, what do we need to do to take the machines from where they are to where they should be? And the first step we do is classify all our equipment. We use simple ABC classification, and we start with the most important machines, meaning the A machines. C machines, when we start, we don't do anything. It's run to failure. So we start with A machines, move on with the learning from the A machines to the B machines, and then do probably some simple autonomous maintenance on the C machines, but that's it. We accept the failures of those. And then we also review, and this is a part which is giving us, when we succeed in those areas where we see a huge benefit, to actually review how we do our inspections, how we do our repair. So, for example, if you're changing a spindle or a motor, do you know how to do shaft alignment? We have a lot of factories where we have hydrostatic spindle breaking down once a year, once every other year. A hydrostatic spindle, it's a shaft with an oil film in between. There should be no metallic contact. It should be like a eternity machine almost. And in most of the cases when we have failures, we can go back to how this was mounted. And we see that there's the fault. So we say you need to use a digital shaft alignment tool. And when you have aligned your shaft, you get a report saying this is okay. Then you can go and you can put that into your CMMS system and say, if this machine breaks down from a spindle or motor perspective, at least it's not my fault. I did it right. So we can eliminate that risk. And then we can look at, okay, if we have a failure, was it because the operator didn't know how to run the machine? Was it that we did something else in the machine which caused this effect? Was it incoming material, which sometimes happen? Then we can start to eliminate failure causes. And then on a monthly base, we review, are we getting closer towards our targets? Of course, it's not a straight line that you reach a 12th of the year target every month, but we should see the direction. And in many of the cases, we need to review what we need to do and how we do it. And in most cases, how we do it. And this is also linking to data, because data tells us how we have done things. So when we start up the machine after an intervention, all the data should be according to tolerances. And we are collecting data from different perspectives. So we are collecting a lot of the data. Wow, that was a cool. I thought it was a laser pointer. From looking at the methods, how we do things. So we get data there when you manually check for vibration. You manually check the tension of the belt. You manually check the quality of something. And then on top of that, we sensorize the equipment in different way, depending on how critical they are and if we feel it's suitable to sensorize them. And we also start to extract more and more data from the PLC systems. And what we have started to see is that from a maintenance department perspective, we are more interested in process data. For example, in SKF, we have a lot of slides on our machines. So in the PLC system, you can measure the torque, the power needed to move the slide, which should be same. Backward, forward, backward, forward, backward, forward. If this slowly increases, then it can tell us something, air leakage, missing lubrication, And then in combination with vibration, it will make us even more certain on what the reason of this beginning deviation is. And with this data, we can plan not just for when we need to stop the machine to correct it, but we can also upfront analyze, can we do something so this will not happen again? So moving from plan to preventive and trying to predict more and more, we are also moving away from traditional planned stops. So many of you might have that every 6 weeks or 2 weeks or 3 months, you stop the machine for X amount of hours to do maintenance. As we get more and more data also over how the production is running, we can, due to, unfortunately, still having an imbalance in our production, we can foresee when a certain machine cell will stand still due to, for example, their outer buffer is full, because due to our regulation, you can't produce more than a certain amount. You can't have too much in your buffer. And then we can utilize that stop to do our intervention and instead eliminate the traditional planned stops. By doing that has put us in another challenge, and we call it, we prepare IKEA packages, because everybody knows about IKEA. So we are preparing boxes, and where in those boxes we put the spares, the bolts, the nuts, the grease, the drawing, the tools needed to perform a certain task. And then we mark that box with a color when everything is in place. And then we have that in place for a certain amount of machine and for a certain amount of man hours. And then we can use, if we have a breakdown or a natural stop due to our imbalance, to conduct that part of the maintenance that we have to do. And this is the way we're working with and have been working for quite a while. And we try to visualize the data in different ways. So both in using goggles, especially for autonomous maintenance, we don't have to go around the machine that much, but also to make it very visual for the service technician. So this is a spindle, and we color dot where in the spindle we start to see a deviation using basic traffic lights, green, amber, red. Amber means we need to do something, but it's not critical. Red means we should stop, because we could have a breakdown that could spread out and be severe in the machine. So more and more data is being collected, for good and for bad. This is also how we do it. So trying to connect the machines, trying to get hold of the data, first offline, then online, starting to analyze. And this is, I would say, where we are in most cases. And in some cases, we have also learned quite a lot from the analysis and can improve the situation. But the challenge is very often what you see up in this corner. We have multiple screens with multiple data. So it's like if you go back 20 years in industry and everybody was inspired by Toyota and Toyota production system, and that the factory should speak to you, and you went into a factory and you saw full walls of graphic showing all data, all KPIs available for the factory. And then at least within SKF over time we have started to think KPIs, K, that means key performance indicator. We had a lot of performance indicators, but very few were key. And we started to reduce the number of data until we had what was key, and what was key to know depending on your function. We are in the same journey again with screens and digital data. We have multiple screens with multiple data, and we have not yet figured out which data is key. Well, now we collect everything, we try to watch everything, and the more machines we start to connect, the bigger the challenge is to get an overview of the data, because we don't have that amount of resources that can sit inside our offices and just flip screens to look at all the graphics. So this is a process we're in where we need to find out how we should use this data. This is another example of a screen. And again, we're using different solutions for it. We say that in most cases we are not mature enough to take central decisions saying this is the system, this is the way. So what we do right now, we more or less encourage factories to try. And like if we have a factory in Spain, we have two guys that are very engaged in new technology, and they do a lot of trial and errors. We have in US the same situation. We have a team there that are very much into technology and develop different things. So what we try to do is keep track of what is being developed, but not saying this is wrong or this is right or this is the standard yet, because we don't know. Also, what we see as the reliability of the machines go up and they become more and more optimized is that we don't have one man, one machine any longer. Meaning, back in the days when you had one operator on each machine, this man or this person was the best sensor we had. Work 8 hours a day standing at the same machine. You learn it quite a lot. Now where we have fewer technicians taking care of more machines, we need to be able to give them the data they need, where they are, and when they need it. So this is also something we are still, I would say, in the trying mode. We started like in Gothenburg, we got everybody an iPhone. But then I had this quite senior mechanical guy in his late 50s showing me his fingers. How do you expect me to be able to type anything on a bloody iPhone? His fingers were like this. So we see more and more that they use iPads instead or other tablets, but they use speak. They use that you can record your voice. Yeah, and then the iPhone writes it out in text, and they take photos. And this is what we see growing dramatically in SKF. People don't want to use their hands to write any longer. They want to speak. And the more they use their device, the more their voice recognition recognizes their voice. So it becomes better. So in a lot of cases, we get a picture and we get a text, but the text is verbally inserted. And in here, we try to have the drawings, the electrical schemes, machine data, the instructions for the task you need. And if we have complicated, we can always discuss what is complicated, but certain tasks, then we do small video clips. So they actually can watch how to do certain things. And this is really starting to help. Still a challenge. We're talking about SKF. It is some managers still consider this as a toy and a luxury toy and not a tool. So this is something we have to overcome. So more or less what we try to do is we try to have the business strategy very clear and with clear priorities. Where are we going? We not always know exactly how we should get there, but it should be clear where we're heading. And that we have the technology following this strategy. It's not something separate. It's an enabler for us to reach our targets. And trying to balance central decisions with local initiative. We are still in a mode where we promote local initiatives to a very high extent. And we use digitalization to lever our lean transformation. And so the first step for lean is to reduce the variation in our production. That's our main goal. In most factories, we're still working with that. So we can have a production with minimal variation, meaning what you start in one end, you can trust it will come out in the other end with the right quality at the right time. Doing that, we start to see that we can reduce buffers quite a lot. Especially we see that the bullwhip effect, meaning as you go backwards in your value chain, it tends to grow quite a lot, these buffers. But by having the variation in production reduced, we can reduce buffers quite a lot. And we can reduce that we start producing extra parts just because we were expecting some of them to turn out as scrap. So we can start what we want to have in the end, and we can trust that that is coming out. When that is in place, then we can start to improve the flow and take off other wastes. But we try to have this full chain, a full value chain from end to end, from customer order to customer delivery, and try to balance that and reduce the variation as much as possible. So, as a summary slide, even though it's a bit blurry, as a foundation, we have the SKF production system. This is our foundation for stability and improvement. Inside production system, you find things like 5S, defined work, value stream mapping, basic tools you need to analyze and stabilize your situation. Then we work very much with flexibility. We must be able to meet variations in demands and act on customer requests. We try to automate more and more. We say as a first target we will not have black factories, meaning you turn the light off, you go home and the factory is running. But we will have black production areas. So we will have areas, and we already started, where we have certain amount of hours where we run the production. For example, a blind shift is probably most of you are aware of. So you run a blind shift, so you go home and then the production should run for 8 hours. Perhaps we will reduce the speed to ensure that the machine will run, and then they have a shift coming again after 8 hours. And we are working with traceability, so we can trace where and when a product was manufactured and how it was. So you're using different types of codes. And the most important thing is the leadership. And this is very often underestimated. We need to get leaders on board. We need to work with competence development. We need to enable them to work with their teams, and also the department structure is getting more and more blurry. We need to cooperate more with other functions. I think in the near future, in some of the areas in SKF, we will change the organizational structure from functional organization to say the ones working on this shift are responsible for the production on this shift. Regarding if you belong to quality, maintenance, production, EHS, or logistics, you are a team. Yeah, I see this as the next step, because we change our technology, we change our way of working, but to some extent we don't change the way we're organized. And I think this is the technology has gone further than our organizational setup, I would say. So this is something we're still working on. I will stop here.
Yep.
Thank
Okay.
you.
Thank you very much, Johnny. Thank you.